Okay, here we go. What if you're an angel? Sini, we may believe that some people were very well behaved as children. Some people, not everybody. So, all right. So your last test was all about functions, and this next test is also all about functions, but we're extending, and we're going to be talking about very specific functions. In particular, we're going to be talking about quadratics in section 2.6. And quadratics is anything that is to the second power. Whoop. Quadratics. And when we get to section 2.7, we're going to take what we know about quadratics and we're going to apply them to word problems. And you guys will do great on word problems because you had so much practice on section 1.6 in your take-home test. You're going to be just awesome at it, and I'm very confident of that. Well, the very interesting thing about quadratics and polynomials that raise in degree are the extreme values. And extreme values are the largest and smallest values in an immediate region. A lot of times you call the extreme values the maximums or the minimums. So is this area right there, is that a maximum or a minimum? It is a maximum. Now, true or false? That is the largest value that the graph ever reaches. False. We can see that there's a lot of values that will be bigger, but it is what we call a relative maximum or a local maximum because it's the biggest in the immediate region around it. And in calculus, we define what that immediate region is later on. So this one happens to be the minimum. And these are really, really interesting points because we need to identify a lot of times like how to maximize profit, how to minimize cost, how to maximize efficiency, how to minimize pain. I don't know, whatever you want to do, but those are important concepts in our world that we try to figure out. And with quadratics, we have maximum and minimum values. And we have two types of equations for our quadratics. This is the first type of equation, and it is what I call vertex form. Your book does not call it vertex form. Your book calls it standard form. I don't know hardly any books that refer to this one as standard form. So if your book says standard form, you cross it out and you think vertex form. I'm sorry, there's no other way to work around that. This one over on the right-hand side is what we call standard form. So if I draw a parabola, and I'm just going to draw any old shape, does that have a maximum or a minimum? It has a minimum. What do we call this special spot right there? The minimum, which is also referred to as the vertex. Anybody want to guess with looking at this equation what the vertex location is? How many units is it shifted horizontally? H. How many units is it shifted vertically? K. So H, K is the location of the vertex. That's what we're going to do tomorrow. Tomorrow I'm going to teach you how to complete the square in a new way, different from what you've done before. But today we're going to work with standard form. And so if you see another parabola and you want to identify that vertex, the way we do it if it's in standard form is we take opposite the b value and we divide it by twice the a value. Once we have the x value, do you know how we find the y value? We plug it in. So if you look at the back of your notes right here, you can see on the back side, I don't give you this on the test. You need to know these, okay? Including the quadratic formula, everything else. But you have vertex form on the left-hand side, and you have standard form on the right-hand side. And you can see that we can tell by looking at it whether it goes up or down. That's whether the a value is positive or negative. It tells you the vertex. It tells you the axis of symmetry. The y-intercept is the c value, or the last value. And then it tells you also how to solve for the x and y-intercepts. So we're going to be working on that side, and that's what you need to become familiar with. So if you need to reference something, there's a little chart here on the back that can help you out, but try to do as much from memory as you can. Question, Carissa D. Yes. Don't know what you're asking. For the direction, so like here you see the A in front. Yeah, so for the direction of the parabola, if it goes up or down, it's dependent upon the A value. And so in both situations, they both have an A. So we just leave it like that. Yes? Okay. All right. 2 examples. That's all we're doing today. These 2 right here. We want to sketch the graph and give its coordinates for its vertex and intercepts. These are not in vertex form, they're in standard form, so away I go. The first thing I identify is A, B, and C. What is the A value of this one? Dos. What's the B value? 0. Because there's no x. Everybody see there's no x term? And since there's no x term, then the b value is 0. What's the c value? Negative 8. Well, in order to figure out the vertex, I do negative b, or negative 0, divided by 2 times a. What is negative 0 divided by 2 times 2? 0. So the vertex has an x value of 0. How do I get the y value? Plug it back in. 0 squared is 0, times 2 is 0, minus 8 is negative 8. That's your vertex. That's how I do it. Negative b divided by 2a, and plug it back in. What is the y-intercept? Your chart on the back says that the y-intercept is always which value? The c value. And so the y-intercept is negative 8. Notice that in this case, it's the same as the vertex. That's not always the case, but in this case it is. Now finally, the x-intercept. If you want to find the x-intercepts, you should take y and set it equal to what? 0. So 0 equals 2x squared minus 8. This is the equation that you need to solve, and that will tell you the x-intercepts, where it has a height of 0. You tell me, how do I solve for this? That's what everybody wants to do. They want to add 8, divide by 2, and square root. That's fine, and you can do that. However, I'm going to show it factored because, like on your test, a lot of people forgot the positive and the negative. So I'm going to factor this out, x squared minus 4, and you can see that that factors to x plus 2 and x minus 2. So, just as Preston said, we have solutions of positive and negative 2. Does it make sense that you have 2 answers? Yes. It's a squared equation, so I would have 2 solutions. I can now graph that. I'm going to make the graph to fit what I need it to fit. Make each one of these tick marks worth a value of 4. And on the side, I'll make each one worth 1. Because I can. That's what I want to do. I plot 0, negative 8. And then I plot my y-intercept, which is also negative 8, same spot. Then I'll plot my x-intercepts, negative 2, positive 2. Now I can draw my graph. Isn't it pretty? How about this? If I want to check the answer, all I got to do is turn on my calculator. I go to y equals, I type it in. I change my window to look exactly like I have it. Negative 3 by 3 with the tick mark of 1. Negative 8 to 8 with the tick mark of 4. I press graph. We've got the same exact thing. Should match your picture identical. You remember this? A little bit of review? Okay, let's try a harder problem then. I need more space, you might as well. Y equals negative 1/4 x squared minus 6x plus 3. Okay? How about this parabola? Does this one go up or does it go down? It does go down. And you can see that the negative 1/4 in front, that's going to shrink it. It's going to be a vertical shrink, and it'll be upside down. Okay? So we should have an idea that this is going to be a wider shape and everything else. So let's start by identifying A, B, and C, and we could tell some other qualities about this. What is A? Negative 1/4, B, and C. There we have it. If I want to take the vertex, I want to find the vertex, I take negative B or positive, negative B is positive 6 divided by 2 times negative 1/4. What is 6 divided by 2 times negative 1/4? Good, so it's 6 over negative 1/2. Dividing by negative 1/2 is the same as multiplying by its reciprocal, so 6 times negative 2 is negative 12. So the vertex has an x-coordinate of negative 12. How do you find the... plug it in. Find the y value by plugging it in. Negative 12 squared is 144. 144 times negative 1/4, negative 36. Minus, what's 6 times negative 12? So negative 72, so we'll add the opposite, it'll be plus, and then plus 3. Negative 36 plus 72 is positive 36, plus 3 is 39. Now, there were a number of mistakes on your test that were arithmetic mistakes. So if you're plugging these back in, you're worried about making a mistake, just substitute negative 12 in for the x and do so with parentheses. If I type it in like this, you can see that I do get the same answer. So, and all I do different is I just type in parentheses around the negative 12, and when you press enter, you do get your 39 to check. Yes, we should be able to do that without typing our calculator. However, I do know that sometimes small mistakes happen, and you want to check. What's the y-intercept? C, which has a value of 3. To find the x-intercept, I take the equation and set it equal to So I have negative 1/4 x squared minus 6x plus 3 is equal to 0. Do you think that that thing factors? No, it does not. And if it doesn't factor, you either have to complete the square or use the quadratic formula. I will not complete the square in these situations. I will always use the quadratic formula. So that's what I'm going to show you. Do you like the negative 1/4 in front? I don't either. How do you get rid of it? If I multiply everything through by negative 4, that will keep the x-intercepts the same. It does not change the answers to the equation. So 0 times negative 4 is 0. Negative 1/4 times negative 4 is 1. Negative 6 times negative 4 is positive 24. Negative 3 times, or 3 times negative 4 is negative 12. Now, let's just think about what we did. True or false? If I graphed these equations, they would look 100% identical. False. This one goes down. This one goes up. So what's the same about them then? The intercepts, where they cross the x-axis. Multiplying through did not change the intercepts. Okay? So we're allowed to do that. So here I have 0 equals x squared plus 24x minus 12. Let's use our quadratic formula, which says negative b plus or minus square root of b squared minus 4ac, all divided by 2a. What is negative b? Negative 24. B squared. 576. Minus 4 times, what's A? Oh, we're using our other one now. 1. What's C? Negative 12. Divided by 2A. How many negatives do you have underneath the square root sign? 2. So they will cancel out, right? Make it plus. Negative 24, plus or minus. Square root of 576 plus 48. $624. When you get to this part on your test, you must write the answer in simplest radical form, and you must express it as a decimal. And we will do both right now. If you don't know what perfect square divides evenly into 624, okay, you can start to check. You can divide by 4, you can divide by 16, 36, all sorts of stuff, okay? If you take 624, though, and divide it by 16, you'll find that it does divide by 16 and 39. So 16 times 39. A 24 plus or minus. If you take the 16 out, it becomes 4 roots of 39 over 2. Are the negative 24 and the positive 4 both divisible by 2? So let's divide them then, and simplify as to negative 12 plus or minus 2 roots of 39. Yay, we found the x-intercepts! You got them! Let's now put them on the graph. And we're going to go back to the front. I'm going to list my values. The vertex you said was negative 12, positive 39. The y-intercept you said was 3. The x-intercepts you said was negative 12 plus or minus 2 roots of 39. That was horrible. 2. Try again. 2 roots of 39. Now, I can plot those first two, but it's pretty tough to plot negative 12 plus or minus 2 roots of 39, isn't it? So let's come up with a decimal representation for those. And all you do is just plug it in. Negative 12 plus 2 roots of 39. And we get 0.49. Then we'll do the next one. Negative 12 minus 2 roots of 39. Negative 24.49. Yes. That'll be a good estimation. No, but you should. We will use these later on, these exact values, so you should get used to. But you're right, that's a good estimation, and for our graph, it would be a good enough estimation. But you should give the exact values to probably about the 100th. So I'm going to make my graph 40 by 40 by 40 by 40. So each tick mark is how much? 10. So I go back 12 and up 39. There's my first spot. I have a y-intercept of 3. Well, that's going to be pretty close down to the bottom here. .49 on the x-axis. You tell me when I reach about .49 on the x-axis. Yeah, right after. That's not even a full value, and each one of those tick marks is 10, so it'll be pretty close there. And then negative 24.49, so 10, 20, not quite 25. There you have it. And you get your parabola. That's how we graph them. I just want to show you one thing. Does that negative b over 2a look familiar? That's your negative b divided by 2a is how we figure out what? The vertex. So the quadratic formula, here's how it is. Negative b divided by 2a is your vertex. That plus or minus square root. That's how you go to each side of that vertex. So that's the amount to each side in order to get your x-intercept values. That's all it is. So if you can remember the quadratic formula, you can obviously remember the vertex and probably anything else that you need. Here's your assignment. Make sure you try these problems tonight. Whoa! Not that one. How about this one? There you go. 2.6, page 204, 1 through 13. Odd. Odd. So you can check the answers in the back of your book. Yes, I didn't make any of those copies yet. The copy machine is broken. Right after I made your 81 copies of this packet, the copy machine up here broke. So I will try to make copies of your assignments out of the book for you so we don't have to wreck all of our books. We can have stuff in here. But that's just 7 problems exactly like we did. Please do your best. Please keep that at the forefront of your work. Don't fall behind this unit. And what's on TV tonight? Monday Night Football. Castle. Wrestling. Dancing with the Stars. I think that there's usually... Oh, I think the Timberwolves might be on it. Anybody know the Timberwolves record right now? 3-0. 3-0. Go T-Wolves.